Imagine a universe where time stretches and shrinks and space itself bends and warps. A universe stranger than fiction. This vision is the legacy of one mind, Albert Einstein. He saw the cosmos as a dynamic, interconnected whole, not a rigid machine. With simple questions, he shattered centuries of certainty and redefined our place in the universe. Einstein's journey began not in a lab, but in the mind of a curious child, driven by wonder and imagination. The story of Einstein is a story of human curiosity, of daring to ask, what if? Our story begins in the quiet town of Ulm, Germany, in the year 1879. Nestled along the banks of the Danube River, Ulm was a place of cobblestone streets, bustling markets, and the towering spire of its famous cathedral. It was here, in this picturesque setting, that a child was born who would one day change the way we understand the universe. That child was Albert Einstein, a boy who, from the very beginning, seemed to see the world a little differently. He was quiet, often lost in thought, and preferred the company of his own imagination to the noisy games of other children. In school, Albert struggled to fit in. The rigid classrooms of 19th century Germany demanded memorization and obedience, but young Albert's mind wandered far beyond the lessons on the blackboard. He questioned everything, often frustrating his teachers with his refusal to simply accept what he was told. When he was just 5 years old, Albert's father gave him a simple magnetic compass. To most, it was just a small object, but to Albert, it was a window into a hidden world. He was mesmerized by the invisible force that made the needle move, and he wondered what mysterious powers lay beneath the surface of everyday things. This single moment ignited a spark of curiosity that would burn throughout his life. The compass became a symbol of the unseen forces that shape our reality, and Albert's mind began to fill with questions about how the universe truly works. As he grew older, Albert found solace and inspiration in books. He was especially drawn to geometry, a subject that revealed the beauty and logic of the world through pure thought. The elegant shapes and proofs fascinated him, showing him that the universe could be understood through reason and imagination. Despite facing discouragement from teachers who saw him as a daydreamer, Albert trusted his own intuition. He refused to let go of his curiosity even when others doubted him. He learned to follow his own path, guided by a sense of wonder and a deep desire to understand the mysteries of nature. This unique blend of wonder and logic became the foundation of his scientific career. Even as a child, Albert was already thinking like a physicist, asking bold questions, seeking hidden truths, and never settling for easy answers. In the quiet corners of his childhood, the seeds of genius were quietly taking root, preparing Albert Einstein for a lifetime of discovery and imagination. Unable to find a teaching job, Einstein became a patent clerk in Bern, Switzerland. The work was simple, giving him time to think and conduct thought experiments, imagining, for example, riding alongside a beam of light. These mental journeys revealed contradictions in the known laws of physics. The patent office, far from academia, became his sanctuary for revolutionary ideas. Each day he honed his ability to analyze problems from first principles. Free from academic pressures, he challenged the very foundations of reality. By day, he was a clerk. In spare moments, a revolutionary, quietly rewriting the laws of the cosmos. The world of physics was about to be transformed by an unknown mind. The year 1905 is remembered as Einstein's Annus Mirabilis, his miracle year, a period that would forever alter the course of science. In just 12 months while working as a patent clerk in Bern, Switzerland, Einstein published 4 groundbreaking papers. Each of these works would have been enough to secure a place in history, but together they sparked a revolution in our understanding of the universe. These papers didn't just answer old questions, they opened entirely new fields of inquiry, challenging the very foundations of physics and inspiring generations of scientists to come. One of his most influential papers explained the photoelectric effect, a mysterious phenomenon where light striking a metal surface releases electrons. Einstein proposed that light is not just a continuous wave, as previously thought, but is made up of discrete packets of energy called photons. This radical idea not only solved the puzzle of the photoelectric effect, but also laid the foundation for quantum mechanics, a new branch of physics that would transform our understanding of the microscopic world. In another paper, Einstein tackled the age-old debate about the existence of atoms. By analyzing the random, jittery movement of pollen grains suspended in water, a phenomenon known as Brownian motion, He provided mathematical proof that atoms and molecules are real, physical entities. This work bridged the gap between the invisible atomic world and the reality we experience, giving scientists a powerful new way to study the building blocks of matter. But perhaps the most profound of all was his special theory of relativity. In this paper, Einstein reimagined the very nature of space and time, proposing ideas that seemed almost impossible to believe. He boldly asserted that the laws of physics are identical for all observers moving at constant speeds, no matter how fast they are traveling. Even more astonishing, he claimed that the speed of light is always the same for everyone, regardless of their motion or the motion of the light source. This was a direct challenge to centuries of scientific thought. The consequences of these ideas were nothing short of revolutionary. Time itself could slow down or speed up depending on how fast you move. Lengths could shrink, and events that seemed simultaneous to one observer might not be to another. Reality, Einstein showed, was not fixed and absolute, but relative and dynamic. Space and time, once thought to be rigid and separate, were now seen as flexible and deeply intertwined, a single fabric called space-time, shaped by motion and energy. From these revolutionary ideas, Einstein derived the most famous equation in science, E equals sine mc2. This simple formula revealed that energy and mass are two sides of the same coin, capable of being transformed into one another. It hinted at the immense power hidden within the atom, a discovery that would later change the world in ways both wondrous and terrifying. With these papers, Einstein didn't just change the field of physics, he transformed our entire understanding of the universe. He inspired a new generation of thinkers, challenged old certainties, and set the stage for the technological revolutions of the 20th century. The age of Newton, which had reigned for centuries, was over. In its place, a new era of physics had begun, one shaped by the bold imagination and relentless curiosity of Albert Einstein. Einstein wasn't satisfied with special relativity. Gravity remained a mystery. He had revolutionized our understanding of space and time, but something fundamental was missing. Why did apples fall from trees? What truly kept the planets in their orbits? The force that Newton had described so elegantly centuries before still defied a deeper explanation. Einstein was determined to find the answer, to uncover the true nature of gravity itself. He imagined a man in an accelerating elevator realizing gravity and acceleration are indistinguishable. His happiest thought. This simple yet profound mental experiment became the seed for a new theory. If you were inside a sealed elevator, you couldn't tell if the force you felt was from gravity or from the elevator accelerating upward. This insight hinted at a deep connection between motion and gravity, a clue that would guide Einstein for years. This led to a radical idea. Gravity isn't a force, but the warping of space-time by mass and energy. Instead of thinking of gravity as an invisible pull, Einstein saw it as the result of massive objects bending the very fabric of the universe. Space and time were no longer rigid and absolute. They could be stretched, compressed, and curved by the presence of matter and energy. Picture a bowling ball on a rubber sheet. Objects follow the curves, not invisible ropes. The heavier the object, the deeper the curve it creates. Smaller objects like marbles roll along these curves, just as planets move along the warped paths around stars. This simple analogy helped people visualize Einstein's complex mathematics, making the invisible visible. The sun bends space-time, and planets follow those curves. The orbits we see are not caused by a mysterious force, but by the geometry of space itself. Even light, which has no mass, is forced to travel along these curves, its path bent by the gravity of massive objects. In 1915, after years of relentless work and sleepless nights, Einstein published the general theory of relativity, a masterpiece of beauty and depth. His equations described how mass and energy shape the universe and how the universe, in turn, guides the motion of everything within it. It was a triumph of imagination and intellect. It predicted that gravity bends light, slows time, and creates ripples, gravitational waves. Light from distant stars would curve as it passed near the sun. Time itself would tick slower near massive bodies, and when massive objects collided, they would send out waves, subtle tremors in the fabric of space-time traveling across the cosmos. The universe was now a living, dynamic fabric. No longer static and unchanging, it could stretch, bend, and even ripple. Einstein's vision transformed our understanding of reality, revealing a cosmos far stranger and more beautiful than anyone had imagined. Einstein's vision was bold, but it needed proof. Could these astonishing predictions be tested? Would the universe reveal its secrets to those who dared to look? The world waited for a test. Scientists and the public alike held their breath, eager to see if Einstein's revolutionary ideas would stand up to the scrutiny of experiment and observation. In 1919, a solar eclipse offered the perfect test of Einstein's theory. British astronomer Arthur Eddington led expeditions to photograph starlight bending around the sun. The results matched Einstein's predictions exactly. Newton's universe was overthrown. Headlines declared a scientific revolution. Einstein became a global icon overnight. His wild hair and gentle eyes became symbols of genius. He used his fame to speak out for peace and justice, not just science. Einstein was bewildered by celebrity, but he embraced his role as a symbol of human curiosity. The world had found its first scientific superstar. Einstein lived through 2 world wars and the rise of Nazism. As a Jewish scientist, he fled Germany for the US, helping others escape persecution. He spoke out against fascism, racism, and injustice, using his fame for advocacy. In 1939, fearing Nazi atomic weapons, he signed a letter urging the US to begin atomic research. Though he didn't work on the bomb, he later regretted his involvement, calling it his one great mistake. For the rest of his life, he campaigned for nuclear disarmament and world peace. Einstein became the conscience of science, warning that humanity's power must be matched by wisdom. His voice echoed far beyond physics. Behind the genius was a deeply human man. Einstein loved music, especially the violin, finding harmony in both notes and equations. He was playful, irreverent, and famously nonconformist. His iconic tongue-out photo says it all. He believed creativity thrived on freedom and humor, not formality. His personal life was complex. He struggled with relationships and family, but these flaws made him relatable. He felt awe for the universe, calling it a cosmic religious feeling. For Einstein, wonder was the engine of discovery. His humility and curiosity inspired generations. Einstein died in 1955, but his legacy shapes our world. General relativity guides our understanding of black holes, the universe, and even GPS technology. His ideas are woven into daily life. Your phone's map works because of his theories, but his greatest gift was his spirit, curiosity, skepticism, and wonder. He showed that breakthroughs can come from unexpected places. Einstein spent his last years searching for a unified theory, an unfinished quest that inspires physicists today. His legacy is an invitation to keep asking, exploring, and dreaming. The universe is full of mysteries. As Einstein showed, the search for answers is the greatest adventure of all.